All right, so we're going to continue talking about circles and stuff that goes on inside of them. We're going to learn two things today, and they're called sector area and arc length. Okay, sector area, arc length. So first thing we need to do before we talk about sector area is know what a sector is. So I'm going to draw a circle, circle C, and I'm going to add in two radius into circle C. So one right here and one right here. Those will be radius AC or CA and radius CB. Now, a sector is this piece right here. So that's called a sector. So it's just a portion of a circle. It's like a slice of pizza or a slice of a pie. This is a sector of a circle. And this is a radius, and this is a radius. So they both have to be a radius for it to be a sector of a circle. And if we want to talk about sector area, well, we know that in this circle C, the area of this circle is equal to pi r squared. So if we wanted to find the area of the sector, we'd say sector ACB. How would we figure out the area? If we look back over at our sector, we would know from our previous lessons that this arc right here, this minor arc AB, would have some measurement. So it would be m degrees. I don't know how many degrees it is. Maybe it's 45 degrees, maybe it's 50 degrees, but it's some degrees. And I know that this entire circle is 360 degrees. So the area of our sector is going to be pi r squared for the area of the whole circle. But we only want this portion. So like if this was 40 degrees, we only want 40 degrees out of the whole 360. So we're just going to multiply the area of the circle by m degrees divided by 360 degrees. And that's all you do. You just do regular area of a circle, multiply it by the ratio of the arc measurement to the measurement of the entire circle, which is always 360 degrees. We'll do an example of it in just a second. The next thing that you need to know about something called a segment of a circle. So we're going to draw a picture very similar to the one we just drew. So we'll call this circle C. And we'll have an A and a B. A segment of a circle may not be quite what you think. If we connect A to B like this, we make this little triangle here. The segment of the circle is this area right here. It's kind of like the crust of a pizza. So the sector is like the entire slice of a pizza, and a segment of a circle is kind of like the crust. So that's a segment of a circle. So one of the things we're going to have to find is the area of a segment. So area of a segment of a circle. So we look here, we have segment ACB. And just think about how you would find the area of this. Okay, I know how to find the area of the sector, right? I could find this whole thing here using this formula. But I just need this little part. Remember, I'm going to know this radius. So I'm going to know this radius. So does it make sense to you that I could figure out the area of this triangle I could figure out the area of this whole sector and then just subtract this triangle out of it, and all that'd be left is the area of the segment. So write down what that looks like. The area of the segment is equal to the area of the sector minus the area of the triangle. We're going to do an example in just a minute of all of these, and you can see how it works. It's very easy, very smooth. So just bear with me a little bit longer. We're going to draw one more kind. There's one more thing you need to know. Then we're going to do a practice problem that'll make all of it crystal clear. All right, so I have a circle here, circle C, A, B, and you know that this is a radius. This is a radius. And you know that from A to B here, that I could find this measurement, and it would be m degrees, right? It would be whatever this is. This would also be m degrees. So we're going to figure out something called arc length. We're going to figure out how long this thing is. The measures we were doing of the arcs before were the degree measures. We're going to figure out how long it is if you walked around it, how far would you walk. So this is called arc length. Okay, so it's real simple. We have circle C. You know that the circumference of that is equal to 2 pi r. Right? So that means you know that if I start here and I walk all the way around back to A, that's 2 pi r. Well, the arc length is exactly like the area of the sector from before, in that the arc length equals the circumference times the ratio of the arc measure to the measure of the entire circle. Okay, this is 40 degrees, it's 40 over 360. We're going to do an example real quick so you can see how all of this works. You've got all that written down already. So I'm going to draw a circle. And we're going to do examples in class too, so don't get too worried about it. You circle A, and I'm going to do the easiest version of this so that you see how simple this can really be. So I'm going to have a radius, and I'm going to have another radius like this. So B, C, and I'm going to tell you that this is a right angle and that the radius is 4 units. And what we're going to do with this is we're going to find the area of sector A, B, C. So we know the area of a sector, the area equals pi r squared times m degrees over 360 degrees. Well, that's pi times 4 squared times our m here is 90 degrees, right? Because this central angle is 90 degrees, so the arc that matches up to it is also 90 degrees. So it's pi r squared times 90 over 360. Well, that's just 16 pi times 90 over 360 is 1/4. And that should make sense to you because this is 1/4 of the circle, right? This is a quarter of this circle. So 16 times 1/4 is 4 pi units squared. So our area of our sector ABC, and really I should be calling this BAC. So, my mistake, BAC. But our area is 4 pi units squared. Now we're going to find the area of segment BAC. So hopefully you remember from your notes that you have just above that segment BAC means just this part, right? And the way we said we did that, so there's that. And now we're going to do area of segment BAC. And we said that the area of the segment is equal to the area of the sector minus the area of the triangle. So we already know the area of the sector. That's right here, right? So we'll do 4 pi minus the area of that triangle. And the area of that triangle is 1/2 base times height. So it's 4 pi minus 1/2 of 4 times 4. So it's 4 pi minus 4 times 4 is 16. Half of that is 8. So 4 pi minus 8. The area is approximately equal to 4.57 units squared. If the problem said leave your answer in terms of pi, that would be your answer. But we're going to round it anyways just so you can see how this all works. And then the last thing we would do is find the arc length. So find the arc length of arc BC. So we have our formula, arc length equals 2 pi r times m over 360. So we just do 2 pi times 4 times 90 over 360. So that's 2 pi times 4 times 1/4. And we have 4 times 1/4. That just equals 2 pi units. Now, think about that. Is it going to be units squared or just units? Remember, it's length. So it's not squared. It's just a distance. It's like the circumference, but it's just a portion of the circumference. So hopefully that's not too confusing for you. We're going to practice it. It's going to get easier. Sometimes it's going to be a little harder when the triangles aren't perfect right triangles with the base and the height easily available to you. But we'll practice it tomorrow. So come in tomorrow ready to work on this.